Hi everybody. Today I want to have a look at question 6, part G of the higher level 2022 Leaving Cert Physics paper. This is one of the short questions. Before I launch into it, I'll give my usual reminders that to make the absolute most out of this video, the best thing you can do for yourself is actually pause it now, go off and try it out for yourself, see how you get on, and use this video to kind of correct yourself, or as a hint to move you on to the next step if you got stuck. Yeah, so it's like I said before, it's very easy to look at somebody doing an answer and think, oh yeah, that's fine, it makes sense, I follow all those steps, I can definitely do that in an exam. But you might not actually be able to when you're looking at a blank page yourself. Okay. And also, as usual, if you have other questions, if you have questions about this, definitely tell me. If you have other questions that have been, you might be going back over a bit of revising for yourself and you're stuck on something, let me know. Even if it's just a general topic that you find hard, I can do a video that's not just questions. Okay. And equally, if you have comments or feedback that you think might make these videos better for you, I definitely want to hear those too. Okay. With that, let's get into it. Let's have a look at the question. So it says, describe how an insulated metal sphere can be charged by induction using a nearby charged rod. Okay, so this is charged by induction. It's kind of in your static electricity section. And this is a very theory question to me. So I'm kind of way prefer a calculation question, but if you love theory questions, this would have suited you. But equally, if you find theory questions hard, I'm hoping that in this video I'll give you an idea of how much detail you need. I think that students often get stuck with either writing too much or too little, and how do I know that I've answered the question and stuff like that. Okay, so let's see how we'll start it off. So I'm going to do a drawing. It didn't ask me to, but it always helps. Even if you're not getting any extra marks, you'll have some start off for yourself, if nothing else. Okay. And to be honest, the drawing can sometimes do the work for you. If my pen, oh, there it goes. Okay. Sorry, my pen's a bit sleepy this morning. Let's see if we can get her going. I'll draw my insulated metal sphere. It's just a sphere on a stand. Okay. The stand isn't super. I'm not going to draw any charges for a second, and now we've got a charged nearby rod. And you might have done this in your lab. You might have charged a rod, like a perspex rod. Well, actually, it's probably not. It could be charged up a rod by rubbing it on a cloth or something like that and bringing it near to your metal sphere. Okay. Now, I'm going to add charges. You could actually draw multiple drawings for this for each step, but just to kind of show you, again, it's a 7-mark question. You mightn't have time to draw 3 drawings of this. They're pretty simple ones, but you might just want to move on. Okay. It doesn't actually matter whether I charge my rod negatively or positively, because the question didn't tell me either way. So I'm just going to make it negative. Some questions might specify, and different materials will get charged in different ways, but I'm going to make my rod negative. And I'm going to write the text at the bottom. I'm just going to describe it for you first. And I also have a sample answer, because my writing on this whiteboard isn't always very neat, but I have some neat sample answers up there. And I'm going to bring my rod nearer to my sphere. And when I bring these negative charges, remember, like charges attract, or negative, or opposites attract, basically. So I'm going to bring my negatively charged rod over here towards my sphere. And on the sphere, it's going to encourage all the positives to come over to this side, if you like. And the negatives are going to be repelled by the negative. So like repels, okay? So you got your negatives over here, okay? And that's all I have in my drawing, and that would cover me for my points, as long as I have a couple of bullet points to explain. Now, usually in physics, you're not expected to write a lot, and I would keep it fairly minimal, just for time and for yourself not to get tied up in knots and things either. Keep it simple. So I'm going to start writing them here, but like I said, I have a clearer version here. That's basically what I said, right? So you bring your rod over here. You've got your charges separated on the sphere. Now, you've only kind of induced the charge, but this kind of setup is dependent on the rod staying put. Okay, but you want to be able to move it away and still have your metal sphere charged. So what you do, you keep your rod close for the moment, then you earth your sphere. So by how you earth your sphere is you touch it with your finger. So then it basically has a connection through you to earth, okay? So touch the sphere with your finger. The negative charge on the sphere goes to earth. So you come along with your hand, lift your finger, put your finger in, okay? The negative charge flows out through you. So all my negatives go out. Okay, and I'll show you how much you actually need to draw. You didn't draw this, I'm just doing it to show you. And then I take my finger away and my negative charges are all gone as well. These will all be gone and I'll end up with a positively charged sphere. Okay, and I can take my rod away too and I'll have a positively charged sphere. That makes sense. So you could see why a couple of diagrams might be handy, but I've chosen to put a few bullet points of text in them, but you could also do something like this and then have the next one almost like, if you like, a comic strip type situation where you describe it. But I would say I would expect that everyone would have some drawings and some text. Okay, so it depends how you want to split it up for yourself, depends what suits you best or how even you remember it best for the exam day. So here we go with the text. I think I would nearly put more drawings and less text, but let's just give an example here, okay? Negatively charged rod. I'm bringing my negatively charged rod close to the sphere. So this is me just going back over the steps now again to tell you, and this is how my answer looked when I was finished, okay? Bring a negatively charged rod close to the sphere. Positive and negative, that's my shorthand for positive and negative charges, they separate on the sphere because the negative charges on the sphere, they want to get really far from the negative charges on the rod, okay? Probably not my best handwriting, but I get in the idea. Now I have the situation that I have up in my drawing and I want to be able to move my rod away. So I keep the rod close for the moment. So keep the rod close. Now you'll all have a version of this in textbooks as well if you want to see a different version, but it's just nice to see it how kind of in an exam paper how you might have an answer of it. Keep the rod close. My goodness. Close. And earth your sphere by touching it with your finger. All right. And what happens is that the negative charges are flowing through your finger. Earth sphere by touching it with your finger. So I'm kind of, if this was in English, it wouldn't be great because I'm kind of leaving out words and I'm abbreviating, shortening things, but it's getting the point across, okay? So I've got the sphere by touching it with my finger. My rod's still next to it now, remember? And the negative on the sphere will flow to earth through you. And again, I just remind you that I've chosen negative and positive. You could do it the other way and you wouldn't be wrong as long as you had the steps correct, okay? Negative charges on sphere flows to earth. Remove your finger. Okay, so I've written all the text, but really it's just an instant. Touch it with your finger, take your finger away, then you can move your rod away and you have a charged sphere. Remove finger and that's kind of de-earthing, okay? So I'll just say that here. I don't know if that's even a proper word, but it's de-earthing. It's no longer earthed. It's no longer dependent on you to give a flow of electricity. Remove finger, remove rod, put it wherever, just far away. And then you have a sphere is positively charged, okay? So my last point, just to say what I have, sphere is positive charged. So I've done what they asked me in the question. They said, how can I charge up? How can an in-metal sphere be charged by induction using a nearby charge rod? So this is induction because you're using something that's charged to make something else charged. It's inducing a charge. The rod is inducing a charge in the sphere. So if a negatively charged rod, bring it near to your sphere. The charges will separate on the sphere because the positives are attracted to the rod and the negatives are repelled. They're going to go as far away as they can. Just keep your rod put for the moment. Touch the sphere with your finger, allowing the negative charges to flow to earth through you. Take your finger away. That only takes a second. Take your finger away. then take the rod away, and you're left with a sphere with just positive charges on it. Okay, so you could see how maybe you could have 2 or 3 diagrams with this either if you wanted. Okay, so hopefully that helps you to give an idea of what you should have in an exam. And I have, like I said, a neater kind of version up online as well. So if you were diligent and you tried this out before watching the video and you think you kind of have it and you just want to check my answer compared to your answer, have a look on there. It's on the website. If it's a thing that you've answered it differently to me, say you've gone for like I said, the kind of comic strip idea of having 2 or 3 diagrams for every step and less text, and you're wondering, would this do? Would I get my marks? You can send it to me and I can check it for you. Or if you don't want to do that, I'm happy to do that. But if you don't want, you can always use the marking scheme on the also on the website. But I will say that just because that got 7 marks this year doesn't mean that exact answer would get 7 marks next year. Okay, that's always a worry with the marking schemes. They change from year to year. So just because you have an answer now that you think is solid and perfect, it was perfect for the 2022 paper, but in 2023 and so on, they might ask for something more. They might be giving the marks out differently. So just be cautious with marking schemes. Okay, they're kind of guidance only. Okay, I think I can leave it at that for this one. Of course, you know to send on questions any way that suits you, and I would love to hear from you. So thanks very much for watching.